కేసు నమోదు చేసినటువంటి నేపథ్యంలో కక్ష పెంచుకున్నటువంటి ముగ్గురు కూడా ఆయన రాత్రి దారుణంగా ఈ ప్రాంతంలో హత్య చేసిన పరిస్థితి ఉంది. దాదాపు 2 నెలలుగా ఈ ముగ్గురు వ్యక్తులతో జరుగుతున్నటువంటి గొడవలపై కూడా ప్రస్తుతం పోలీసులకు క్లారిటీ ఇచ్చారు. కాబట్టి ఈ ముగ్గురు వ్యక్తుల్ని కూడా చంపి ఇక్కడ నుండి పారిపోయిన తర్వాత ముగ్గురు వ్యక్తుల్ని శంషాబాద్ ఎయిర్పోర్ట్ వద్ద కూడా ఈ ముగ్గురు వ్యక్తులను పోలీసులు అదుపులోకి తీసుకున్నారు. సో ఈ మొత్తం వ్యవహారంపై కూడా ప్రస్తుతం ఇంకా పోలీసులు దర్యాప్తు చేస్తున్నారు. ఈ ముగ్గురు వ్యక్తులు లొంగిపోయినప్పటికీ మాత్రం
runtime polymorphism, right? How to implement the runtime polymorphism. In runtime polymorphism, what we have to do? Runtime polymorphism we can implement by using function overriding, right? So what is meant by function overriding? So when the same function is defined in the base class and derived class, the function in the derived class will override to the function in the base class, right? So still, in order to implement the runtime polymorphism, we have to use virtual function concept here. So because to implement, to link the function call with the function definition during the runtime, right? So this dynamic binding. So in order to use this to implement the dynamic binding, what we have to do here, we have to declare the function in the base class as virtual function, right? By using the keyword virtual, so that the which will implement the dynamic binding. Dynamic binding means, you know, the linking of the function call will will link with the function code, function definition during the runtime here. So that means in that what we have to, how we have implemented that linking. Simply we have created the base class pointer object, and we have created the derived class object, and we have made to refer the base class pointer object to refer the derived class object here, right? So that means base class pointer is pointer object is initialized with the address of the derived class object, and we call the both base class version and derived class version by using that pointer here, right? So that means in that the virtual function is having a definition in the base class, and the same function is having the definition in the derived class. So then what is meant by pure virtual function, right? So the pure virtual function means a function for which we don't have implementation. So that means whatever function you declared in the base class, for that we don't have any implementation. It has only declaration, but the declaration is initialized with 0 here, right? So then such a function we can call it as a pure virtual function. So you can see the definition. A pure virtual function, we can also call it as abstract function. Abstract function in C++ is a virtual function for which you don't have any implementation. We only declare it. That function doesn't have any implementation, but we have to declare it. Already I explained you what is the difference between declaration and definition. The pure virtual function is declared by assigning 0 in the declaration here, right? So how it will be, I'll show you the example. This is the basic definition. You can see here, we have a class shape here, and we have the function area. So this is the function area here, and this function is declared with the keyword virtual. So we call it as a virtual function, and it is initialized with 0 here. So that is what we are calling it as a pure virtual function. And is it having any definition of this function here? Is it having any definition of this function? Definition includes what? Definition includes what? Body of the function here. Is this function having the body of the function? Yes. Just tell me, is this function having the body of the function?
No, sir.
No. So, but it is having only a declaration of the function. This declaration is assigned with the value 0 here. This is 0. So, virtual double area equal to 0. So, this is declared in the class shape here. So, this is the base class here, right? So, this function is called pure virtual function here. So, that is what you can go for the definition once again. In the definition, so pure virtual function in C++ is a virtual function for which we don't have any implementation, right? And we only declare it, and pure virtual function is declared by assigning 0 in the declaration. So in the example you can see here, so which is declared and assigned with the 0 here. So such a function we can call it as a pure virtual function. Why we no need declaration in the function here. You can see we have a shape, class shape here. So it is a base class. So here we have a function area here. So which shape area do we know exactly? Which shape area we need to calculate here? Can we define here?
No, sir.
Can we define here? Which shape area we need to calculate here? Can we define here? We
No,
don't
sir.
know exact shape here. Actually, we don't know exact shape. So that is what the definition here is not not uh, cannot be defined here, because if you know the area, if you know the shape exactly, suppose if shape is rectangle, we can define the area function by using rectangle area formula here. If shape is triangle here, we can calculate the area of a triangle. If shape is square, we can calculate the area of a square. But it is the generic term here. We have given the term is what here? Shape. Shape is what here? Generic term here, right? So we have not given any exact shape here. So that is what, to which geometrical shape area we need to calculate. We cannot clearly define here. So that is what, so we have to use a pure virtual function here. So this pure virtual function is having only a declaration of the function, but not implementation. And with this declaration is initialized with value 0 here. Is it clear? So then what is abstract class? Here, as per our syllabus, here we have the pure virtual function and abstract class. So abstract class also is same. Sometimes the implementation of all functions cannot be provided in the base class because we don't know the implementation. Such a class is called abstract class here. Such a class is called abstract class here. That means implementation of all functions cannot be provided in a base class because that implementation we don't know. So the same example you can see here. So here we don't know the implementation of the area function because which formula we have to use to calculate area of shape? Do we know here in the definition? Suppose if you want to, if you try to implement this area function within the shape class shape here. So which formula you need to use to calculate the area of the shape? Do we know exactly?
No, sir.
No, we don't know because here it is a generic term. It is a general term here, shape. We have not given any specific shape here. So that is what we don't know the implementation. So that is what we have only declaration of the function. It is the same thing is telling the abstract class definition. Implementation of all functions cannot be provided in a base class because we don't know the implementation. Such a class is called abstract class, or we can also call it as a class which is having at least one pure virtual function. Such a class is called abstract class here. We can also define a class which is having at least one pure virtual function. Such a class we can call it as a abstract class. See, now shape. Can we say it is abstract class? Can we say the shape is abstract class here?
Yes, sir.
Yes, because we have not defined the area function here. We have not given the implementation of the area function, and it is also having the pure virtual function. So we can also define a class which is having at least one pure virtual function. Such a class we can call it as an abstract class, because the class shape is having the pure virtual function. We can call it as an abstract class here, right? And one more point, very important point here: for abstract class we cannot create objects like our normal class here. Suppose we have a class shape here. Can we create the object class shape? Shape obj is equal to some new shape. Can we create the object for the shape class?
No, sir.
No, sir.
No, sir.
We cannot create. For abstract class, we cannot create the object. But one thing, we can create the reference to the object. That means we can create the pointer of this class. So that means shape asterisk obj. So asterisk obj is what here? Pointer to this class. So we cannot create object, but we cannot create the reference here. You can see we cannot create object of the abstract class, but we can create the references here. So this point important. So now you can see the complete example here. So class shape here. So this is abstract class declaration. We have the virtual double area. It is a pure virtual function. And this is class is base class and class rectangle. This is the class derived from the class shape. So public shape here. So which the derived class will have the implementation of the pure virtual function here. Because class rectangle is derived from the shape here, right? So because class is a rectangle, which is this class is giving specific shape here, because rectangle. So in class rectangle, we can implement the area function here. So here we can, because we have the name rectangle, it is giving the specific name to the specific shape here. So we know the formula of rectangle. By using that formula, we can implement the area function within the class rectangle here. Right? Is it clear? Yes,
Yes.
understood. Understood.
Yes, sir.
Okay. So this is about pure virtual function. Now I will give the complete example. So see, you can see here class shape here, and it is an abstract class, and it is having the pure virtual function, virtual double area equal to 0. So this is the pure virtual function here, and close the declaration of the abstract class. Now, in order to implement the pure virtual function, we have to derive the class here. So now class rectangle, which is derived from the public shape class here, in which it is having total local variables, double length breadth here, and public here. It is a constructor which is used for initializing length and breadth here. Double L comma B here. So here we are using length equal to, so length equal to L and breadth equal to B here, and here we are implementing double area. So this is the implementation of the virtual function here. So double area return length into breadth here. Now close the class declaration. Is it visible to you?
Yes,
Close.
sir.
Now we have go for the main function. The main function create the rectangle class object here. So here 5.3, 3.4, right? Area will be there here. Just I'll copy this. You can see the implementation of this. So this class is called abstract class. Now This is the constructor. So the spacing is most important for your understanding purpose here. So you can, it will be very clear which block is started at which line and which block is ended here. You can clearly understand here. This is what here implementation of the virtual function here. So in the implementation of virtual function, what we have written here, which is calculating area of a rectangle. What is, you know, the rectangle formula? What is the rectangle formula? Rectangle area formula. What is the rectangle area formula?
Length into width.
Length into breadth.
So here double area written length into breadth here, right? So now here we have created the object of the rectangle class only. We have not created the object of the shape class, right? Because shape is what here? Abstract class. Can we create the object of the shape class? Can we create the object of the shape class? Just now I told you for abstract class,
No.
can we create the object? We cannot create, but we can create the reference, but we cannot create the object here. So that is what here we have created. You can see here now rectangle R1. See, this is the rectangle constructor, derived class constructor. Here length and breadth values will pass here, which is initializing length and breadth here. Now double area here. So which is calculating area of a rectangle, that is length into breadth, and return the result here. Close the declaration of the class rectangle. Now define the main function. Within the main function, create the object. This is the object of the rectangle class. We have created object of the rectangle class, not shape class here. And in that we have passed the two values, length and breadth values, 5.3, 3.4. So then which will initialize length and breadth here. Now again here we call the R1 dot area. So by using object of the derived class, we call the area function, right? Member function. So which will call this area member function, which will return the value here, right? Now we can see the output. Area, area of rectangle is this one. Got it? This is the output here. Now, so you can see here, this is the pure virtual function which is declared in the class shape and which is defined in the class rectangle. Likewise, you can also define, suppose if you want to create a class, Control C, you can create triangle here. Triangle. So you can create what is the area of triangle here? 0.5 into length into breadth. You can say, or height into breadth. Instead of length, you can write here height. Height here. Height into breadth here. Now we have created one more triangle. So one more class derived here. So from same base class shape here. Same base class shape here. Now here, how many derived classes are there from the same base class? How many derived classes are there from the same base class? Can you tell? Yes. triangle. So T1 object we have created. Suppose 5.2 comma 3 3.0. This is height into breadth. Right. Now you can create Control C, Control V here. Area of triangle is this is T1. We have to call the object T1. Now, so this is what type of inheritance? Can you tell? Class shape. It is a one base class. Rectangle, which is derived from the shape class. Triangle, which is also derived from the shape shape class here. So one base class, two derived classes. It is what type of inheritance? Can you tell? This is what type of inheritance? Hello? Hello? Please respond, any one of you.
Yes, sir.
This is what type of inheritance?
Hierarchical.
Yeah, it is an hierarchical inheritance, right? So what we have done here, we have created object of the rectangle class and triangle class, right? So now we call the R1 dot area means which call the version of the rectangle class, and T1 dot area means which call the version of the triangle class here. Now you can run, see the output. Oh, sorry. So you got the output. So this is area of rectangle and area of triangle here. In both cases, so you have the, suppose here if you want to refer these uh, by using the base class, if you want to call the area of this one, in order to implement the runtime polymorphism, what we have to do here, we have to create the base class pointer, SHAP shape as strict BPTR. Here BPTR means what here? Shape BPTR. It is an object of the base class. Yes. Is it possible to create this object of base class? Just now I told you this is shape is the base class, right? Can we create the base class object? Can we create the class shape object here? Yes. Class shape is an abstract class because which is having pure virtual function here. Can we create an abstract class object? Yes or no?
No, sir.
But we can create the reference. But we can create the reference to that object here. So reference means we can create the pointer asterisk BPTR, right? So now by using this pointer here, just you can what we have to do is create the initialize BPTR. This is the pointer, initialize the rectangle object with address of the rectangle object, right? BPTR ampersand R1. Here you call this function by using base pointer, right? Similarly, you can check it once. Just I have created the base class pointer reference. We have not created object here. Reference means it is a pointer which is initialized with address of R1 object. This is the rectangle class object, and which is I'm calling the area function. That is a virtual function by using the base class pointer here. So here you can see by which version of the which class version of this area function will be called. Which class version? We have the area function implementation in rectangle class as well as triangle class, right? So here and base class shape class is common for both rectangle class and triangle class here. Now I am calling the area function member function by using the base class pointer. Now, which version will be called? Which definition will be called? Rectangle clause definition or triangle clause definition? Here, in this. So, have you seen my link here? My cursor, is it visible to you? Hello? In this line, you can see in this line here. So, I called area function by using base class pointer. Is it visible to you? My cursor is visible to you?
Yes, sir.
So here, which version of this area function will be called? That is, which implementation? Rectangle implementation or rectangle class implementation or triangle class implementation? Here, base pointer is initialized with what? BPTR is initialized with what? Address of R1. R1 is object of which class?
Rectangle.
Rectangle. That means the pointer content is what? Address of rectangle object. So I called by using base pointer area here. Then which version will be called? Which version of the area function will be called? Rectangle version or triangle version?
Rectangle.
Rectangle version will be called here, right? So now you can see the output. You got the same output, right? So similarly, you can implement for this. In order to implement the dynamic runtime polymorphism, you can create initialize BPTR equal to ampersand T1 now. So this is the base pointer is initialized with address of T1. Now you can call with now you can see now you can observe we got the same output. Why? Anyone of you, can you tell why we got the same output? Can any one of you tell the why we got the same output here? What changes we have to do in order to get the rectangle output and rectangle area value and triangle area value? See here in triangle when we created the triangle object here T1 5.2 comma 3.0 and base pointer is initialized with T1. After initializing the base class pointer with address of T1, we have called the area functions here. So then what is the current value of base pointer? What is the content of the base pointer? Which object address is there in the base pointer? Base class pointer?
Triangle.
Sorry, which one? Triangle. So that is what when we call this one, so which will print as triangle area only, right? So in order to print the rectangle area, what we have to do is Control X, Control V here. Now here base pointer is initialized with rectangle address here. So what is the content stored in the base pointer here? Address of R1. Now you call the area function by using base pointer, which will print rectangle area value. After that, again triangle T1, right? Object is created and base pointer is initialized with address of T1 here. Now when we call this area function with the base pointer here, which will call the triangle version here and display the area of the triangle here. Now you can see the output. Now you got the correct output here. Now you got the correct output. Yes. So this is about runtime polymorphism implementation by using pure virtual function. So in the shape class, we have declared only declaration of the virtual function here. Is it clear? Any doubts in this? Any doubts? Yes. Please tell me, do you have any doubts in this?
No, sir.
Okay, so there are few points regarding this abstract class. You can see a class is abstract if it has at least one pure virtual function here. So you can see in this class test here we have the virtual void show. So this is a pure virtual function. Okay, and int get, it has a definition. Even it is have other function is having the definition, because it is having at least one pure virtual function. The class test is called abstract class here. Right. Similarly, we can have pointers and references of abstract class type. In previous example, I explained you. So we can have the pointers and or references to the abstract classes. So here, this is an reference. This is what? A reference of class here, or pointer of abstract class here. It is not an object here. It is a reference of abstract class or pointer of an abstract class here. Right? So this is here. We can have only pointers and references of abstract class type here. So you can see in this example, is it visible to you? Class base, we have the virtual void show function is there. It is a pure virtual function. And we have the class derived from the base class here. We have a definition, implementation of the show function. So it is derived here, in which what I did here, I create the base class pointer only and initialized with address of the derived class. New derived means what here? New derived means what? In shortcut I have written here. So you can create object of the base derived class, like here you can write derived equal to some derived b equal to d is an object of the derived class. You can initialize with address of d here. Both are equal. So instead of writing this step here directly, I have used base asterisk bp equal to new derived here. So that is the reason for your understanding. Small changes I did here. Now BPTR show function. Just previous example already I explained here. So here what we use here, we have created only reference or pointers of the base class, but not created object of the base class here. Right. Similarly, if we do not override the pure virtual function in the derived class, then derived class also becomes an abstract class. Suppose you can see here, I will show this one here. Control C. If you want in implementation also, I will show you. See, class base, which is having what here? Pure virtual function. But when a base class is having the pure virtual function, derived class must have the implementation. Class derived public base, it must have the implementation of the show function. Is it having the class derived is having the implementation of the show function here? Yes. Class derived law show function implementation on the, is it there or not? Have you implemented the show function in the class derived? Is it visible? కనిపిస్తుందా మీకు?
Yes, sir.
Show function implementation on the derived class law. We have the virtual void show. It is a pure virtual function. It is what here? Pure virtual function here. So it is declared in the class base here, but it must be implemented in the derived class. Did we implement it in the derived class?
No, sir, we didn't.
We didn't implement it in the derived class. So that is what the derived class also becomes the abstract class here. Derived class also becomes the abstract class. How do you? So for the abstract class, we cannot create object. You can see here. So here you will get an error. will say you. You can confirm that. See, derived D cannot declare the variable D to be of abstract type derived here. So a class derived also became the abstract class here because we have not implemented the show function in the class derived here. If you implement the show function in the derived class, so then the class derived is not an abstract class here. So this is about this point here. So this is about third point. Understood the third point? So we have one is first point is a class is abstract if it has at least one pure virtual function. So because the class test is having the one pure virtual function, we can call class test is an abstract class. Second point is we can have pointers and references of the abstract class type. So here we have created the pointers and or references of the abstract class because class base is an abstract class which is having the pure virtual function, right? So we have created the references pointers. And if you do not override the pure virtual function in the derived class, that means if the derived class is not having the implementation of the pure virtual function, then derived class also becomes the abstract class. So this is the example I have shown. And what is the fourth point here? An abstract class can have constructors also. See, this is the one point here you can remember. Control C. I will take the attendance at the end of the class. For them only I will give the attendance. Most of the students are leaving. See, this is the class base here. In the class base, we have the virtual class, right? So this is virtual function here. Virtual void fun is a virtual function. So we have the constructor. This is what here?
పెద్దమ్మ ఈ ఫోన్ మారకపోదు అంట. ఈ ఫోన్ వేడైతుంది చోవాడ పెట్టుకుంటే ఏమన్నా అవుతుందని.
Yes. See, base int I. So this is what here? Constructor in the base class, right? Base class constructor. This is base class constructor here.
ఒకసారి మొత్తం ఎంత బరువు ఉందా ఫోన్?
Yes, please mute. Now this is derived class constructor. So derived class constructor. Anyway, derived class can have the constructors, and this is an implementation of the virtual function. You can see this is a class base here. One member data member is X here, and this is a pure virtual function. Virtual void fun is a pure virtual function, and base int I, base class constructor, which is used to initialize the data member X. So X is equal to I here. Now close the base class declaration. Now class derived. So class is derived from the class base here in public mode. Class derived colon public base class. It is having its own data member Y. And here we have the derived class constructor derived int I comma int j. So one parameter is for initializing the local variable, that is a derived class data member Y, and another parameter is for initializing the base class data member X here. So that is what we are passing two parameters here, I comma j. So in this one base of I, so that means the value of I we are passing to the base class constructor here, and which is initializing X value here, right? So now we are here in the definition of the derived class constructor, we are writing only one statement, that is Y equal to j. So that means the Y is data member of derived class is initialized with j here. This is the implementation of the fun function. So this fun function will display the X and Y values here, right? So now Now you can see this is abstract class, right? Class base is an abstract class which is having the constructor. So that is the meaning of this one here. You can see the point. An abstract class can have the constructors also. So it is having the constructor. So base I for initializing its own data member. Now, and I created the derived class object, passed the values 4, 5. So that is x is initialized with 4 and y is initialized with 5 here, and which will call d dot fun is means which will call the virtual function. So we are calling the virtual function by using derived class object only. So this is derived class object, right? And this one. Just wait a minute. So you got the x equal to 4 and y equal to 5. So x is initialized with I and y is initialized with j here. So x is initialized by using base class constructor. Base class is an abstract class. So that is what abstract class can have the constructors also. This is about 4th point here, right? So next, is it clear? Any doubts in this? Yes. Any doubts? Okay. So next one is virtual destructors in C++. So we have virtual destructors. What is meant by virtual destructor? So deleting a derived class object using a pointer to base class. So the base class should be defined with a virtual destructor here, right? So we have to what we have to do here, derived class object ni delete cheyali. Then basis koni by using pointer to a base class object. And a base class pointer use చేసుకొని derived class object ని delete చేయడానికి we have to declare base class should be defined with a virtual destructor here. In the base class we have to declare a virtual destructor here, right? So for that we have to use a virtual destructors here. The purpose of virtual destructor is to delete the derived class object by using the base class pointer. So you can see this is the class B here and public B. B is an constructor. Yes. You can see the example here. So this is what here. This is what? Base class. Enter my base class constructor. This is base class constructor here, right? And now just constructing object message here. So virtual tilde B here. This is a base class destructor here, and its definition I have written simple message here. Cout destructing a base here. Next, close the base class here. Next class derived D. Shall I copy it in editor so that you can clearly understand? Control C. I'll go to the editor here. You can see. So class B, it is the base class and it is having base class constructor. So it isn't simply displaying the message. B is a base class constructor constructing base here. Here we are using virtual tilde B. So it is a destructor here, and because it is defined by using the keyword virtual here, so that is what becomes a virtual destructor here. Okay, so basically it is a destructor, and it is defined by using the keyword virtual here, became the virtual destructor here. And in the definition of the virtual destructor, simply it is displaying the message. destructing base here and close here, and finally close the base class here. Close the base class. Now class derived D. Class derived class is D here. So which is derived from the class B, base class here, and it is having its own constructor D. So it is constructing derived here. Next, it is also having its own destructor D here, right? So it is not base class destructor here, only its own class destructor here, D. Now, so it is simply displaying the message destructing derived object here. Now close the derived class. This is a close, derived class is closed here. Now you can see here D, class D. This is a class D here, asterisk derived. So new D here. So this is, we can call it as a derived class object. So it is, you no need to use this asterisk also. So this is a derived class object, derived D derived. D is the class name here. You can see class name is D, and derived is a derived class object here. New, with new operator, object is created. Now B equal to B asterisk BPTR. It is a base class pointer. Yes, B is what here? Base class name. B is what here? Base class name. Asterisk BPTR is the base class pointer name. We equal to derived here, which is initialized with address of the derived. You can suppose if there is no asterisk here, simply you have to use ampersand operator here. Ampersand operator, both possible here. Suppose if you use the asterisk here, because new operator allocates the memory for derived class object and returns the address of the that memory that will be stored in the pointer asterisk D. That is what we no need to use the ampersand operator here. So both cases are possible. So you can create D or you can use the ampersand operator here. If there is no asterisk here, so you have to use the ampersand operator. If there is an asterisk here, you no need to use the ampersand operator here. I think it is visible to you. Kanpistundamma? Right? So D, it is a derived class object, and this is a base class pointer, and which is initialized with address of derived class object. Now I am using here, right? Here what? Deleting derived class object with base class pointer. See, BPTR is what here? Which class pointer here? Please tell me, BPTR is what? Please respond. BPTR is the base class pointer which is initialized with address of derived class object here. So now delete BPTR. So delete BPTR means what? Delete BPTR means what here? Base pointer, base class pointer lo ఏముందమ్మా ఇప్పుడు?
Derived class.
Derived class address ఉంది. So delete base class pointer అంటే meaning ఏంటిది? You are deleting the derived class object here, because base class pointer deleting means the content which is stored in the base class pointer, that is address of derived class object, will be deleted. That means you are deleting the derived class object here and return 0 here. So can you say what is the output of this one here? So in which order the constructors of base and derived classes will be called? ఏ ఆర్డర్లో కాల్ అవుతాయమ్మా? టాప్ టు బాటమా, బాటమ్ టు టాప్? Constructors are called from top to bottom order. Destructors are called from bottom to top order. Already I explained you. You can see constructing base. See, when the object of the derived class is created, so then first which class constructor will be called? This constructor will be called here, constructing base. After that, this constructor will be called constructing derived. You got these two messages here, constructing base and constructing derived here, right? After that, I initialize the base class pointer with the address of derived class. Now I call the I used a delete operator. So when I used a delete operator, which will call the destructors here. So which class destructors will be called first? Derived class destructor. So you got destructing the derived class and then base class destructor here. So destructing the base class here in that order. So destructors are called from bottom to top order, and constructors are called from the top to bottom order here. So this is destructing base. After calling the destructing, after calling this destructor, then which will call the base class destructor here, right? But constructors are in reverse order here. So that is what you got this output here. Is it clear? Understood? Please respond. Any doubts in this?
No, sir.
Okay. So only few members are responding. Next, like pure virtual function, we also in C++ it can also support the pure virtual destructors in C++. So the pure virtual destructor is possible in C++ because if a class contains pure virtual destructor, it must be provide a function body for the pure virtual destructor here, right? So we must provide the function body to pure virtual destructor. You can see here. But basically in pure virtual function, does it have the function body? In pure virtual function, we have seen in the base class, does it have the function body? Function definition, is it there function definition in pure virtual functions? Only declared in pure virtual functions. Pure virtual functions are only declared in the base class and assigned with value 0. Here, the pure virtual destructors are declared, assigned with 0, and it is also having the definition here. You can see it is also having the definition of the pure virtual destructor here. So this is B, and its implementation, scope resolution. This is a destructor. Cout pure virtual destructor is called, and close this one here. Next to class D, derived class, which is derived from the base class. This is the derived class destructor, right? Now you can see here, I will show you an editor. So this is the implementation here. So we have the definition of the pure virtual destructor here, right? So this is a destructor declaration, virtual tilde b of functional operators equal to 0. This is a pure virtual destructor declaration. This is the definition of the control C. You can see here definition of pure virtual destructor. Now this is a class D derived from the class base class, and it is having its own destructor, and now its own definition here. Now I created the base class pointer reference and initialized with the derived class object here, and delete the derived class object by using the base class pointer here. So the destructors again called in the reverse order. Again, see, the first derived class destructor is called, its message is displayed here till D is executed. After that, the base class destructor is called. Pure virtual destructor is called here, right? There is the order of calling the destructors are same. Only here difference is in pure virtual functions, it doesn't have implementation in the base class, but whereas pure virtual destructors which have the implementation or definition. Implementation is nothing but definition of the destructor. So it is defined here, right? So that is called pure virtual destructor, right? This is the last topic in the unit 3. So in the next class, we'll start the unit 4. Any doubts in this unit 3? Hello? Okay. Thank you.
Thank you, sir.